Hello kids, Shubhamangalam Eclectic Scholar. Myself Sudeep. I'll be taking up class 6 today. So I'll be taking up science for you, and we were done with the first lesson and the study material portion also for the first lesson. Now we need to start the second lesson here. The name of the second chapter is Playing with Magnets. So you must have come across the terminology magnets before also. So let's see what all do we know about magnets. Okay, there are few questions that have been asked to us. Let's try to solve them. Have you ever seen a pin holder in your school or home? How does the pin holder look like? It looks like a pen stand basically, and the only difference is going to be, instead of pens, it is going to have pins which are going to be attached, okay, to the mouth of the pin holder. So why do you think the pins are getting attached to the mouth of the pin holder and they're not dropping down? Okay, why do you think so that is happening? That is one reason. There's something else also. You must be having refrigerators at home, and you must be seeing that there are certain, stickers stuck on them. Not those ones which you peel out and you stick it up, but there are something like toy magnets which are stuck on the refrigerators. For example, if this is your refrigerator, you have a picture in your textbook also, but I prefer drawing it over here so that you clearly see what am I actually trying to tell you. So if this is a refrigerator and there is a magnet of an apple shaped fruit over here, okay, so why do you think the magnet is not falling down? Why do you think the apple sticker is not falling down? Why is it still stuck to the refrigerator unless and until you push it down? There must be something that is holding the material. Okay, so you must have heard about toy magnets also. Whenever a toy is running, or whenever you screw a toy, you notice that the toy and the machinery parts in the toy are striking each other with the help of certain magnetic tools. Okay, we have further questions over here. We need to find objects that get stuck, not by glue or adhesive. Okay, without using the glue or the adhesive, there are still some objects which are getting stuck to each other. Most of these objects that you come across are the metals and the magnets. Okay, most of these objects are basically metallic objects. What do you mean by metallic objects? Give me some examples. Iron, copper, aluminium, steel is an alloy, of course. But all these metallic objects, when they come in contact with a substance called as magnet, they are going to get attracted to it. For example, a coin. If I had a coin in my hand and a magnet in another, I would be able to, attract both of them and stick the coin to the magnet and hold it in one hand only. Okay, that is one thing. So basically it is just the metallic objects and the magnets which are going to get stuck to each other. Let's study about further objects. Let's study why do they get stuck. So what materials are needed to make magnets? So we have come to a certain terminology called as magnets. We came to an understanding that magnets are these substances which are making the refrigerator stickers stick on the refrigerator doors, and the magnets are the substances which are helping the pins to get attached to the mouth of the pin holder. So what are these magnets made up of? How are these magnets made? From where do we get these magnets? Are they natural or they artificial? What do you mean by natural? Are they occurring from the earth's crust, or are they made by man? We need to find out that. So how were the magnets discovered? We have a very beautiful story for this. So before we move further, can you see something on the board over here? Can you see the dust is stuck to my board over here? Why do you think this is happening? Because this is a magnetic board. Okay, and there must be some material in the duster which is helping it to hold on to this magnetic board. So we need to find out that what kind of materials are these. Along with the duster, can you see two tiny magnets over here? They are also stuck to this board because this board is a magnetic board. So do you understand? This is how magnet works. Okay, it gets attached to certain materials which are nothing but magnetic materials. The materials which get attracted to a magnet are called as magnetic materials, and the materials which do not get attracted to a magnet are called as what? Non-magnetic materials. If I try to stick my marker to the magnetic board, I am not able to do that because this is not a magnetic material. Okay, But when I stick my duster or place my duster to the magnetic board, there must be something here that is actually able to attract the magnetic board. It must be some magnetic material. Similarly, I have two magnets over here. If I bring this magnet closer to this magnet, you can see that the first magnet is moving away. Okay, now if I change the position and I try to stick them together, they are getting attracted to each other. There must be something that they are possessing a certain attraction and repulsion policy. Let's study about this. Before this, we need to come across some certain terminologies over here. Okay, so we have the word magnet. What is a magnet? Magnet are substances which get attracted to other magnetic substances. Now, magnetic material. What do you mean by magnetic material? Magnetic material is a material that gets attracted to magnets. For example, iron, aluminium, copper, etc. All these materials get attracted to magnets. That is why they are called as magnetic materials. What is the next word? Non-magnetic material. Non-magnetic material. What does this mean? Materials that do not get attracted to magnets are called as non-magnetic materials. Okay, for example, rubber, scale, plastic. Now I told you that this board is a magnetic board and this marker is made up of plastic. So is this marker getting attracted to my magnetic board over here? No, how much ever I try to stick my marker on the magnetic board, it is not happening. But if you see this iron magnet over here, or it's this iron piece over here, it got attached to my magnetic board right away without any pain over there. It is just stuck to the magnetic board. Can you see those iron triangular pieces over here, which are nothing but magnets? They got attracted to my magnetic board because they are magnetic materials. The marker is not getting attracted or not getting attached to my magnetic board because it is not a magnetic material. That is why it is called as a non-magnetic material. What are the other examples of non-magnetic material? Rubber, scale, and plastic, as it is. I told you about the marker. What else do we have? We have the North Pole and the South Pole. If you have studied about maps, you will know what is North Pole and the South Pole. But here, you will be studying about the magnetic North Pole and the magnetic South Pole. Okay, basically using a compass. We have pictures of compass in our textbook also. The next word is magnetic compass. What is magnetic compass? Magnetic compass is a device which helps us in knowing different directions like north, south, east and west. Okay. Who uses magnetic compass? People who travel a lot, okay, who go on journeys and voyages on ships, the mountaineers, the people in the defense like the army, troops and all these people use magnetic compasses. Why do they use a magnetic compass? So that if they are not aware of in which direction are they moving, the magnetic compass guides them and lets them know that they are going in a certain direction, whether it is north, south, east or west. Like poles and unlike poles. What is like poles? Similar poles are called as like poles. Like if I consider two magnets, the north pole of the first magnet and the north pole of the second magnet. This means I'm talking about the same poles. Okay, north and north. The same poles of two magnets or more are called as like poles. Okay, similarly, if I talk about the north pole of the first magnet and south pole of the second magnet, this means I'm talking about two different poles. When I talk about two different poles of a magnet, they are called as unlike poles. So like poles, unlike poles. Next, attraction, repulsion. What do you mean by attraction? And what do you mean by repulsion? So if you see these two magnets over here, when I get this magnet over here, it is just pushing the first magnet away. This is repulsion. Repulsion means going apart. Attraction is the opposite of repulsion. What is attraction? Coming together. Okay, we are talking about magnets over here. When the magnetic poles are coming together, they possess a property called as attraction. When the magnetic poles or magnets are going apart, they possess a property called repulsion. Now when I push this magnet over here, it got attracted to the first magnet. Now if I change the pole, it is pushing the magnet away. You see this? It is pushing the magnet away. They are not getting attracted to each other. So this is called as repulsion. Fine. So we will study about this further. Then there is a very good terminology called as magnetic induction. What is magnetic induction? Transfer of the magnetic property from one magnetic material to another magnetic material with the help of a magnet. I am repeating, transferring the magnetic property from one magnetic material to another magnetic material with the help of a good magnet is called as magnetic induction. We will study about all these terminologies in our exercises over here. Before this, we need to read the story. So I want you to open your textbook, okay, your class 6 science textbook. We will read the story together. So let's come to page number 13, 1-3, story of the magnet. So we have come across many terminologies over here. What is magnet? What is magnetic material? What is non-magnetic material? We have seen what is attraction, repulsion. We have seen what kind of objects are, getting stuck on the board, on the magnetic board over here. What objects are not getting stuck. Okay, so basically we need to understand where did this magnet come from. Page number 13, 1-3 class. We have the story of the magnet over here. Let's read it together. Around 2500 years ago, there lived an old shepherd. Who's a shepherd? Somebody who takes care of the sheep and the goat. Okay, sheep basically. There lived an old shepherd named Magnus. He used to take his goats and sheep to the hills for grazing. He always carried a wooden stick which had an iron cap. Remember, he is having a wooden stick which is having an iron cap. Iron is a magnetic material or a non-magnetic material? It is a magnetic material class. He was always carrying a wooden stick which was having an iron cap. And what was his name? Magnus. What was his profession? He was a shepherd. Where did he go? He went to the hills so that his ships could do the grazing and all. Okay, grazing is like basically eating grass. One day, while his goats were grazing, Magnus dipped his stick into a spring of water and poked at the pebbles and stones at the bottom with it, like somebody is fishing. Can you see the picture over here? Okay, he's standing by the side of the river and he was poking his wooden stick into the stones and pebbles which were inside the water. Okay, and what was he having in his hand? He was having a wooden stick which was having an iron cap. So he was poking the pebbles and the stones inside the water with the help of a stick. So what does he observe? I repeat the statement. Magnus dipped his stick into a spring of water and poked at the pebbles and stones at the bottom with it. Suddenly he felt something pulling his stick. Even when I am, pushing this magnet over here, I can see some pulling or pushing force. Similarly, Magnus was also able to experience a certain pulling force. Whenever he was dipping his stick and poking the pebbles, he observed that there is a pulling force which is pulling his wooden stick inside. Let's see what is it. Suddenly he felt something pulling his stick. When he took it out of water, he saw a stone stuck to the iron cap. So if this was his wooden stick, okay, and if this was the iron cap, to this a stone was attached. Because when he pulled it out, he saw a stone attached. Why did the stone get attached? Let's see. The stone which Magnus pulled out was called as lodestone. What is the stone that Magnus pulled out with the help of his wooden stick that was having an iron cap is called as lodestone. This was the first initial name of magnet. Okay, it is a natural magnet and possesses the property of attracting iron. Please underline that statement. Lodestone is a natural magnet and has the property of attracting iron. Iron is a magnetic material. So who was the man who discovered about magnets over here? What is his name? Magnus. Around how many years ago? 2500 years ago, 2500 years ago. What was he basically doing? He was just moving with a sheep so that his sheep could graze the field over the hills and all. So what was there in his hand? He was having a wooden stick. What was the speciality of the wooden stick? It was having an iron cap. What was he doing with his wooden stick? He was poking the pebbles and stones which were present inside the water. Okay, what did he observe? That his, stick was being pulled by a certain force which was present on the pebbles. What did he do? He removed the stick from the water and he found a stone or a pebble stuck to the iron cap of his wooden stick. What is this stone called as? It is called as the lodestone. What is lodestone, class? Lodestone is a natural magnet which has the property of attracting iron. Okay, so this is because actually the lodestone that later became our new magnet that we use it everywhere. Okay, so basically this is a story of magnet. Further, we are going to discuss about different shapes of magnets. Let's see. So the lodestone that we were studying about is a natural magnet, but the magnets that we were talking about in the beginning of the lesson, like the magnet present in the pin holder, the magnet present in the refrigerator toys or the refrigerator, this duster magnet, this magnetic board, all these are nothing but artificial magnets. So you need to understand that magnets are of two kinds: natural magnets and artificial magnets. The magnets that we see around us, like in different objects, are basically artificial magnets. So magnets have different shapes and sizes also. We have four shapes mentioned in our lesson over here. The first shape is called as the bar magnet, where one pole will be the north pole and the other pole is going to be the south pole. The first kind of magnet that you see over here, the first size or category of magnet that you see over here is a bar magnet, most often used. The second is a horseshoe. How does a horseshoe look like? It is U-shaped. So one pole of this is going to be north, the other is going to be south. Half of it is going to be red in color, the other half is going to be in blue in color. You must have seen it in cartoons like Tom and Jerry and all. Like, they use magnets to trouble each other, or build some havoc for the other person, like that. So this is in shape of a horseshoe. It is U-shaped. That is why it is called as a horseshoe magnet. The next is a ring magnet because it is ring shaped. Okay, so the upper or the lower portion can be either north or south or vice versa. Similarly, you have a disc magnet that looks like a disc. So this is a disc magnet, this is ring magnet, this is a horseshoe magnet, and this is a bar magnet. Okay, so we need to talk about substances or objects, whether they get attracted to magnets or not, depending upon their properties, whether they get attracted or repelled when they come in contact with magnets. For example, if I consider a jump clip, the jump clip or the paper clip, the iron one, not the plastic one. Okay, if I consider the jump clip, for example, the bulletin board pin also, you can consider that. All these are made up of steel and iron alloys, basically. So they have given us this table and they say that jump clips which are made up of iron get attracted by magnets because iron is a magnetic material. Do you understand? The second example that they give is the normal scale that you must find in a geometry box. Okay, the scale is made up of plastic and it is not getting attracted to magnets. So does this mean that scale is a non-magnetic material? Yes. Something else. Let's consider the wooden scale or the wooden stick. The wooden scale or the wooden stick, is it going to get attracted to the magnet? No. But then what happened with Magnus? What was the speciality in his wooden stick? He was having an iron cap. Remember, even though he was holding a wooden stick, the upper portion or the wooden stick was having an iron cap and the pebble got attracted to the iron cap, not to the wooden stick. Do you understand? So a wooden scale or wooden stick is not going to possess any kind of magnetism and it is not going to get attracted to magnets. So you are going to write a no over here. Fill up the table on page number 14. Now, aluminium. Aluminium, you find aluminium in your vessels, the utensils that you use in your kitchen. So please write here aluminium, if the aluminium, and right over here utensils. Basically we are talking about utensils as the object, and what are utensils made up of? Aluminium. So aluminium is also a metal, and I told you in the beginning of the chapter that metals are the most famous magnetic materials. So aluminium, does it get attracted to magnets? Yes. Next, I've mentioned iron here over again. Let's take some other iron object. Let's take an iron rod. Is the iron rod going to get attracted to a magnet? Yes, a definite yes. Let's take one more example. Okay, let's take your eraser. What is the eraser made up of? It is made up of rubber. Is the rubber eraser going to get attracted to a magnet? No. So what do you conclude from this? Can we identify two different types of objects over here? Something that is getting attracted to magnets and something that is not getting attracted to magnets. So materials which get attracted to magnets are called as magnetic materials, and materials which do not get attracted to magnets are called as non-magnetic materials. So what did you study by now? You studied that there are natural and artificial magnets. What was the example of the natural magnet? It was the lodestone. Artificial magnets, the fridge magnet, the pin holder magnet. Okay. Now you studied different shapes of magnets over here. What were the four different shapes we studied, class? It was the bar magnet, it was the horseshoe magnet, it was the ring magnet, and it was the disc magnet. Now we studied about different objects that are made up of different materials, and we tested whether they get attracted to magnet or not. So we came to a conclusion that there are two types of substances. Substances which get attracted to magnets and substances which do not get attracted to magnets. Something that is getting attracted to magnets is called as a magnetic material. So there must be some magnetic material in this duster over here. That is why it is getting attracted to the magnetic board. Yes or no? Similarly, the marker does not have any magnetic material, so it is not getting attracted to the board. Okay, so this is a non-magnetic material and this is a magnetic material. These two iron magnets made up of iron getting attracted to the magnetic board. Okay, now look at this. If I push, okay, even though the first magnet is not in contact with the second magnet gets pushed away on its own. It is going away on its own. Can you see this, class? Okay, to push if I try to push just the first magnet towards the second magnet, what am I trying to do? I'm trying to push the first magnet, the above magnet, to the below magnet so that they get attached. But that is not happening. Instead, what are you observing over here? We can observe that the second magnet is going away whenever I try to bring the first magnet closer to the second magnet. Okay, what is this property called as? It is called as repulsion. We studied in the new words today. What is repulsion? Going away. Do you understand? I am trying to bring the first magnet closer to the second magnet, but the second magnet is going away from the first magnet. So this is possessing what kind of property? It is possessing repulsion. Okay, similarly, if I try to turn the magnet also, still it is moving away. Now look at this magnetic board over here. This duster got attracted to the magnetic board. Okay, this means there were like poles over here. Fine, if I try to put it like this, it is not getting attached to the magnetic board. If I try to put it like this, it is not getting attached to the magnetic board. Similarly, it is not getting attached to the magnetic board. But once I place it like this, it does get attracted to the magnetic board. So we need to study about certain poles of a magnet. Okay, so you need to understand that there are two poles of a magnet, the north pole and the south pole. Okay, when we were studying the new terminologies, we came across like poles and unlike poles. Okay, we will study about it. So class, moving further, we have a question over here. Can we separate iron filings from the soil? What are iron filings? Iron materials, or the left out iron scrap that you might find. For example, if you to go to a welder's shop or something, if he's scraping iron out of iron rod, the left out iron dust is called as iron filings. You find this iron dust in the soil also. Soil is nothing but the mud. So they are asking us, can we separate iron filings from the soil? For example, if you take some soil, okay, soil has nutrients. So along with nutrients, it is going to also have some magnetic dust. So if I take iron magnet and I roll it on the soil and I take it out, I can see some particles stuck to my magnet. These particles which are stuck to my magnet when I was rolling it on the soil is called as iron filings. So yes, we can separate iron filings from the soil. What did I do? In a paper, I'm going to consider some soil over here taken from my garden or from the school or somewhere like that. Then I'm going to take a bar magnet and I am going to roll the bar magnet onto the soil. When I roll the bar magnet onto the soil and I take it out, I see that there are certain particles stuck to my magnet over here. These particles are nothing but the iron filings which are separated from the soil by me with the help of a magnet. So yes, we did it. Now let's come to the second question. Poles of a bar magnet. You need to understand this is how a bar magnet looks like a bar chocolate. Okay, it is going to have two poles. And what are the two poles, class? North pole and the south pole. So what are we talking about? We are talking about the bar magnet, and the bar magnet has two poles, the north pole and the south pole. You need to understand, where is the magnetic strength the highest in a magnet? Is the magnetic strength inside the magnet equal at all the parts of a magnet? You see these extreme corners of the bar magnet. These two extreme corners are called as the poles. Okay. This is definitely the central portion. You need to understand, where is the magnetic strength, where is the magnetic field the highest. So to understand this, what do? I take a paper. I take a paper and underneath the paper I am going to place a magnet. On this paper I am going to drop some iron filings. What is iron filings? Iron dust. Okay, you can write it over here. Iron dust or iron scrap or iron particles. So what did I do? I want to find out, where is the magnetic strength the highest in all the parts of a bar magnet. I need to test that. So what did I do? I take a white paper and I place the bar magnet below the white paper and I drop some iron filings over this. As I move the magnet, I see that the iron filings, gather at a certain position with few in the middle. If I see more amount of iron filings at these two ends. What are these two ends? When I see below, they are nothing but the poles of the bar magnet. Do you understand? So what do I conclude from this? That the poles of the bar magnet are going to have the highest amount of magnetic strength when compared to the central portion of the bar magnet. For example, if I place this on a table or on a white paper and I drop some iron filings on this, I tap the table, okay, so that the iron filings align in their position. You will observe that the iron filings get mostly attracted to the poles of the bar magnet, thus signifying that the poles of the bar magnet are going to have high amount of magnetic strength when compared to the central portion of the bar magnet. So what is the conclusion here, class? What magnet are we discussing about? We are discussing about the bar magnet. How many poles does it have? Two poles. What are the two poles? North pole and the south pole. What is the speciality of these two poles? They are going to have high amount of magnetic strength. Okay, they are going to have high amount of magnetic strength, which is going to help them to attract to other substances. What about the central portion of the bar magnet? Does it possess any kind of magnetic strength? Yes, it does possess magnetic strength, but that magnetic strength is much lesser when compared to the poles of the bar magnet. The pole strength is much more dominating when compared to the magnetic strength of the central portion. Okay, So what did we study? Two poles. What are the two poles? North pole and the south pole. What is the speciality? The magnetic strength is going to be very high at the poles. You need to remember this, that the magnetic strength is the highest at the poles. And what are the two poles that we are talking about? The North Pole and the South Pole. Now, the third question that we need to talk about is finding directions with a bar magnet. Now, how do you find out the direction in which the bar magnet is? Okay, so if I take a stand over here, okay, and I attach a string, and to the string I'm going to attach a magnet. If I suspend the magnet freely, if I hold the magnet freely with the help of this stand, you will observe that the magnet after some time comes to a rest position. That rest position is nothing but the north-south direction. Okay, now understand what am I trying to tell. I am using a stand over here, and to the stand I have attached a thread. To the thread I have attached a magnet over here. After some time the magnet comes to a rest position. In that rest position it is not moving further, because in that rest position it is nothing but in the north-south direction. Do you understand this property of the suspended bar magnet? Coming to a certain position which is nothing but the north-south direction is called as the directional property of the magnet. What is it called? Directional property or the directional property. Okay. What do you mean by directional or the directional property over here? The directional property over here is like when you are going to hold the bar magnet freely for a certain amount of time, it is going to come to rest in a certain position, in a certain direction. That certain direction is nothing but north-south direction. Do you understand? I am repeating. If you are holding the bar magnet freely from a certain position, after some time the bar magnet is going to come to rest in north-south direction. Okay, when the bar magnet comes to rest in the north-south direction, it is possessing a property called as the directional property of the bar magnet. What is it called? It is called the directional property. Along with directional property, the magnets are going to have two other properties. What is it? It is attraction and it is repulsion. I told you when we were talking about terminologies and the new words over there, attraction is when the magnets are coming closer to each other or coming together. Repulsion is when the magnets are going apart. How did I show you repulsion over here? When I was trying to push this magnet, the second magnet itself goes away from the first magnet. So this means they are possessing the repulsion property. Now if I turn this magnet and I try to bring it closer to the second magnet, can you see both those magnets attached? All this while in the entire period, in the entire video, when I placed it over here and I was trying to push it closer to the second magnet was going away from the first magnet. This means that they were possessing the repulsion property. Now when I turned the magnet, this means I changed the pole of the magnet and I brought it closer to the second magnet. What did I observe? That they have come closer to each other and they got attracted right away. Do you understand? So this means along with the directional property, the magnets are going to possess two further properties called as attraction and repulsion. So what did we study in today's class? What did we study? We studied about different types of magnets that we see around ourselves. Okay, we see magnets on the refrigerator, we see it in the pin holder, we see in this magnetic boat over here, and we see in the metals like iron, aluminium and all. So how are the magnets categorized? Natural and artificial. Yes or no? Natural magnets are the magnets which are occurring in the nature. Artificial magnets are the magnets which are made by man. So what are the different shapes and sizes of magnets that we studied? We studied four shapes. What were they? It was the bar magnet, it was the horseshoe magnet, it was the ring magnet and it was the disc magnet. Now we studied that some materials get attracted to magnets and they are called as magnetic materials, whereas some materials do not get attracted to magnets and they are called as non-magnetic materials. And what else did we study? We study that you can separate the iron filings from the soil with the help of a magnet. Yes or no? This was the soil which was placed on the paper, and what did I do? I roll a magnet on it. When I remove the magnet, I can see iron dust attached on it. Yes or no? In this way, I removed the iron dust from the soil. Second point, what did we study? We studied about the two poles of a bar magnet. How many poles, class? Two poles. What are these two poles respectively? North pole and the south pole. What is the speciality of these two poles over here? It is going to have the highest magnetic strength in the bar magnet. Okay, high amount of magnetic strength is going to be concentrated at the poles in a bar magnet when compared to the central portion. We were having an activity for this. Yes or no? We were having a white paper below which you are going to place the bar magnet, and on top of the white paper you are going to drop some iron filings. You will see that the iron filings get gathered at two ends. What are these two ends when you look at the magnet? It is the north pole and the south pole. You see very few iron filings gathering at the central portion. Okay, that is because the magnetic strength at the central portion is lesser when compared to the magnetic strength at the poles. Now, we studied about a very special property of the bar magnet, the directional property. What is the directional property? You have a stand over here and you are going to suspend the bar magnet freely with the help of a thread. Suspending is nothing but holding at a certain edge, holding from a certain point. Your fan is suspended from a certain point. What does this mean? It is fixed at a certain point. Okay. So what was I telling? We studied about a very special property of the bar magnet over here. If you are going to hold the bar magnet from a fixed point, okay, if you're going to hold the bar magnet from a fixed point for a certain amount of time, you will observe that the bar magnet is going to come to rest at a certain direction. What is this direction, class? It is the north-south direction. What property is this of the magnet? It is the directional property. What does the directional property signify? The directional property signifies that whenever a bar magnet is suspended freely from a certain point, it is going to come to rest in the north-south direction. This property is called as the directional property. Along with directional property, what are the other two properties I showed you with the help of these two magnets over here? It is attraction and repulsion. Attraction is when the magnets are coming together. Yes or no? Right now, what is the property being possessed by the magnets over here? It is the attraction property. And what is repulsion? When the magnets were going away. How will the magnets go away? If I turn the pole and I try to attach it again, but it is not getting attached and actually moving further. It is not even coming closer to it. So do you understand? How much ever I try to attach both of them, it is not happening. But if I turn the pole and I try to attach them, they get attached right away. Okay, so these three are the properties which are possessed by magnets. The directional property, when the bar magnet is suspended freely, comes to rest in the north-south direction. The attraction property, magnets get attracted. Now, repulsion property, magnets also move away from each other. Okay, now we will study why do the magnets get attracted and why do the magnets get, move away from each other, because of what is the reason. We need to study about this in the other video. Thank you for now. So class, on page number 16, figure number 5, I want you to open your textbook and look at figure number 5 on page number 16 in your science textbooks class. So what do you see over there? It is nothing but a device, and this device is called as magnetic compass. What are the parts of this magnetic compass? It is a disc that is having a glass covering, and it has needle inside it that is going to show you certain directions. Like basically it has the north-south needle, which is going to help you to know the other directions also. How do you differentiate between north and south? The pointer which is going to point the north is always going to be in red color. Okay, so who uses this magnetic compass? It is used by the mountaineers, it is used by the people, the army troops, and people who go for long voyages and journey and long traveling via ships. So why do they use this? Somebody who's going for treasure hunt also will definitely have a compass with them. You must have seen in movies like Jurassic World or the Jumanji movies and all, they always have a compass with them. So why do they have a compass with them? Because they might get lost, or if they want to know in which direction are they moving, the compass helps them in knowing the direction. Okay, so the compass is going to have a needle where one portion of the needle is going to be covered in red color, and that red color points to the north, whereas the other part is going to point towards the south. We will study about the magnetic compass in much more detail in the further activities. For now, you need to know that it is a device used to know the directions. Okay, and this device is used by mountaineers and many other people who want to know the direction in which they are moving. It has a glass covering, it has a disc, it has a needle. Okay, so now coming to the two properties that we were discussing after directional property, it is attraction and repulsion. Okay, attraction when the two magnets were coming together, repulsion when the two magnets were going apart. Now we need to study why were the two magnets coming together and why were the two magnets going apart. Okay, so now you can see two bar magnets over here, and you can see that the north pole of the first magnet is facing the north pole of the second magnet. Can you see these arrows over here? These arrows signify that the magnets are moving away from each other. They are possessing which kind of property here? They are possessing the repulsion property. I repeat, how many magnets do we have in the first case over here? We have two magnets. Magnet number 1 and magnet number 2. What is this? What is happening in case number 1? The north pole of the first magnet is facing the north pole of the second magnet. And you can see these arrows over here. What do these arrows signify? That the magnets are moving away from each other. What is this property of the magnets moving away from each other called as? It is called as the repulsion property. Okay, so this means when similar poles of the magnets are facing each other, the magnets are going to move away. What are the similar poles also called as like poles? So you need to understand this statement that like poles of a magnet repel. Okay, what did I say? When the similar poles of the magnets are facing each other and they are brought closer to each other, they are going to move apart. Okay, so what are we going to understand? A new statement over here, that like poles are nothing but the similar poles. Like poles repel. Okay, similarly, look at the second case. This is magnet number 1 and this is magnet number 2. The south pole of the first magnet is facing the south pole of the second magnet. But we have arrows again over here which are showing that the magnets are moving apart. Why do you think the magnets are moving apart in the second case also? Because here also the similar poles are facing each other. So what statement are we proving over here? We are proving the statement that like poles repel. What do we understand by this? That when similar poles of a bar magnet, of two bar magnets, if similar poles of two bar magnets are brought closer to each other, they are going to move apart. What does the statement mean? That like poles repel. What does the word like means? Similar. What does repel mean? Go away. So you understand the statement that like poles repel. Now let's study what is the second statement. Okay, so if when we were doing this, magnet activity over here, and when I turn this magnet and when the magnets are going away from each other, this is the first magnet, this is the second magnet, and they are going away. Why do you think they are going away? This means that this pole and this pole are the same. Do you understand? This means the like poles are facing each other, and that is the reason that the second magnet is going away from the first magnet. It is not coming closer to it. So what does this prove? It proves that like poles repel. Look at the third case. We have the magnet number 1 again and the magnet number 2, but we have a difference over here. The south pole of the first magnet is facing the north pole of the second magnet. And can you see these arrows over here? They are facing each other. These arrows over here signify that the magnets are coming closer to each other. So this means they are possessing the property of attraction. Okay, do you understand? There are two magnets over here. The south pole of the first magnet is facing the north pole of the second magnet. We have two arrows over here which are also facing each other. What do these arrows signify? That these magnets are coming closer to each other. When the magnets are coming closer to each other, what kind of property are they going to possess? They are going to possess the attraction property. Okay. Now, when I overturn this magnet and I change the pole over here, this magnet gets attached to the second magnet over here. This means these two poles are unlike poles. Do you understand? So, we study a new statement over here. Unlike poles attract. What do you mean by the word unlike? Unlike, something that is not similar, something that is different, dissimilar. These two poles are dissimilar. These two poles are similar. These two are dissimilar. Let's look at the fourth case. Fourth case, the magnet number 1 and 2 again. The north pole of the first magnet is facing the south pole of the second magnet. What do you understand? And can you see the arrows over here? So you need to think what is happening. By now you should understand what is happening. This means that the magnets are moving together and they're coming closer to each other. Why are they coming closer to each other? Because different poles of the magnet or dislike poles or unlike poles of the magnet are facing each other, and I'm bringing them closer. When I bring them closer, both these magnets will get attached to itself, to each other. So what does this prove? That unlike poles attract. So what are the two new statements that you have studied by now? Like poles repel, unlike poles attract. What is like? Like is similar. What is repel? Repel is going away. This means similar poles, when they are brought together, they are going to move apart. They are not going to get attracted. They are not going to get attached to each other. Now, look at the second statement, unlike poles attract. What do you mean by unlike? Unlike means dissimilar or different. When dissimilar poles or dislike or different poles like the north pole of the first magnet and the south pole of the second magnet are brought closer to each other, they are going to get attracted to each other. They are going to come closer and get attached to each other. So what statement is it proving? Unlike poles attract. So this statement is proved by case number 3 and case number 4, and the first statement is proved by case number 1 and case number 2. The first two cases possess the property of repulsion and the second two cases possess the property of attraction. Okay, to wind it up, what were the three properties? The directional, attraction and the repulsion. Direction property, when I hold the bar magnet freely from a certain position, it is going to come to rest in a certain direction. What is that direction? North-south direction. That is why that property is called as directional property. Okay, what were the other two properties? Like poles repel and unlike poles attract. Like poles repel, which property class? Repulsion property. Unlike poles attract, attraction property. You will study about the directional property further, much better in much detail when comparing the directional property to the Earth's magnetic field. For now, try to understand these two statements, like poles repel and unlike poles attract. Thank you for today.